All right. Hi, everyone. So mainly for today, I want to go through drawings for your telescope and then microscope, because these are the things that normally your school teacher tend to ignore, or sometimes they just go through. And the problem is what? The drawing actually, right, exam can come out on. And the point is, if they come out in exam, right, the drawing probably going to cost you like what, 6 marks or even more, because normally for essay, right, they will ask you to draw and they ask you to choose, like, what kind of lens are you supposed to use, what is the power of the lens you're supposed to use, stuff like that. So that's why drawing is quite important, because let's just say you don't know everything, just drawing only itself, drawing of microscope or telescope, basically they give you 6 marks. Now each, not both, basically drawing for microscope 6 marks, drawing for telescope 6 marks. But of course, definitely it's gonna be like one only exam. They don't ask you both. And also one thing is, you're not gonna get empty pages. They don't give you a graph paper and they ask you draw. Don't worry about it. They will normally give you the diagrams, everything set up nicely for you, and then you have to draw yourselves. Okay. The idea is you just complete your drawing. That's the main point. Okay. Now, so what I want to do now is I would like to share with you how it works. Okay. Now we start from telescope first, and then we go for microscope, because telescope in a way is more simple compared to microscope. I mean, not so difficult in a way. Okay, so you can try drawing using a graph paper, all right? And then the thing is what? I already said they will be drawn nicely for you, means you got everything set up nicely one. But of course you can say, can I, do I need to draw everything out myself? Do I need to draw like literally blank pages like that? No, okay? You simply just need to know how to complete the drawings, okay? Of course, knowing the drawing is quite important as well, all right? Now, so first of all, of course, you get your principal axis, all right? You can put your graph paper horizontally, as in like imagine your paper like that, okay? You put horizontally this way. Yes, because you're gonna need more space, because this is a double drawing. Because telescope, microscope is called compound lenses. Compound lens means what? Basically, it's combination of both, all right? Hold on, all right, so let me continue. So what happened is, for telescope, right? Why is this more simple? Because this drawing is more specific. All right, you're not gonna get like different locations and stuff like that. No, basically, right, for telescope, there's only one answer. Okay, because for telescope, right, the location are very specific one. Where the image form, where you put your object is all fixed. All right. Now, for you can try drawing using a graph paper. All right. Now, you can use any scale you want to, but normally I will recommend a number, all right? Because what happened for telescope, microscope, they are both compound lenses. So that means you're gonna have 2 lenses, okay? But anyhow, both of them are convex, okay? Both of them are convex lens. So you have objective lens, and then you have you have your eyepiece lens, and then you have objective lens, both of them, okay? So you definitely have like 2 pieces of lens here. But the thing is what? Number one is you need to know the distance between them. And second thing is, what is the focal length to use? Now, these are the things that you don't have to worry in exam, because it's always provided. They will let you know, like, the focal length of this thing is how many cm, and you follow only, all right? So let's say for here, for telescope, right, what happened is that we will have eyepiece, we have objectives, okay? Now, for telescope, your power of eyepiece will be larger than objective lens one. These are the requirements they want you to know. But of course, you have to understand one thing, power is 1/f. So if your power is bigger, right, the focal length actually terbalik one, they will become lower, they become lesser. So that's why over here, right, you FE will turns out to be lower, or shorter than FO, okay, because higher power may equivalent to shorter focal length. Understand? All right. Now, so, and these are the first thing you want to know. Make sure later, right, when you're choosing your focal length, sometimes what they do or not, they're gonna give you 2 lenses, and then they say, oh, this lens focal length is 5 cm. This one is 3 cm. You have to decide on your own which one to be your eyepiece and then which one to be objectives. How we do that? Simple. You follow this one here. Okay, you simply take the focal length. Okay, eyepiece, objective. You must choose the longer one for your objective. You choose a shorter focal length for your eyepiece. All right. Now that's the first thing. Second thing is what? Now there are 2 lenses, so that means there will be distance between them. So these are the distance between them. We call them as L. For telescope, it has to be equals to FO plus FE. It has to be equals to FO plus FE. So what happened for this, right? Simple. Let's say for this case, right, now, first thing I decide the focal length first. Again, I already said you can, you don't have to worry about the focal length one. you probably ask like, should I memorize the focal length? Must I use it every time? Not necessarily. It depends. Just that normally I will recommend this number for you. Now, since my focal length of objective has to be longer than eyepiece, right? Now I will put I'll put 6 cm for this, and then I'll put 2 cm for this. Yes. Now, is there any specific reason? No, just that these are easier to draw. I prefer this drawing. I mean this measurement. But of course, can we use other number? Of course can. As long as your FO is larger. So you could do like 4 cm to 1 cm. You could do like 8 cm to 5 cm, whatever you want. Just that when you have a graph paper, they're not too long, isn't it? You cannot use too much of, you can't do like 10 cm and then 2 cm. You got not enough space on. So that's why I normally recommend 2 and 6. All right. You can use other number, your choice. All right. Now, so you settle this already. Your FO, FE settle. Then next thing is what? You need to know the distance between your lens. As I said, right, for telescope, the distance between them is FO plus FE. So that's why, right, for this one here, 2 and 8, if you sum them up together, it become 8 cm. Sorry, 2 and 6, if you sum them up, become 8 cm. All right. So what happened? You have 2 pieces of lenses, right? Now, basically, why is it called eyepiece and objectives or not? Because simple, objective means the lens that is pointing to object. Objective, all right, pointing to object. And then eyepiece, that means the one that you're looking at. Telescope, normally you got one, look at it, and then there's another big one pointing at the stars and everything. That's the idea. Okay, so eyepiece is the one that you look at. Objective is the one pointing at objectives. All right, pointing at object. You can put anywhere you want. Let's say if I like my eyeball to be here, so the lens nearer to the eye will be eyepiece. The one on the other side will be objectives. Okay. Now, since objective, it's longer. So what happened is you want to make more space here because 6 cm. Right now, 6 cm for your graph paper is like 3 boxes, 3 units. So you need to have more space. So try not to put your lens too far. Too over to the left side. Normally we put somewhere around here. Okay, somewhere around here. Now, for mine, right, because I don't really having a graph paper, this one is just a grid. So you don't have to be exactly same as mine. Okay, your drawing might be a bit different than mine as well because mine is not exactly a graph paper. All right. So what I do is I assume 2 units and then 2 boxes like that as 2 cm. So I'm gonna measure 2 cm, 4 cm, and then 6 cm. I mark this as my FO. Okay, objective focal length. Now, of course, as you know all right, for your lens, it's always 2-sided. Meaning what? Focal point should have both sides. Left hand side also got, right hand side also got. So that's why here also 1, 2, 3, 4, 5, 6. 6 unit, 1, 2, 3, 4, 5, 6, 6 unit here. This one will be my FO as well. Always now both sides. FO. All right. Now next one, the question comes. You need to decide where do you put eyepiece. As we say, the distance between your lens must be 8 cm. So what do you do? Very simple. You measure from here, the middle point, not the curved part, the straight line part. You measure 8 cm. 1, 2, 3, 4, 5, 6, 7, 8 here. All right, here, this is where you put your another piece of lens, which is what we known as the eyepiece. So here we have the objective lens, right? Here we have the eyepiece. Normally these are given in exam, just that I want to start from scratch so you can understand everything detailed. All right. So this one is my eyepiece, the one I stare at. Now, what's my focal length? What is my focal length for eyepiece? As you can see, 2 cm, right? So from the lens, I measure 2 cm to the right side, 1 and 2, I get this. So this is my FE. And then now you look from the left, from here you measure 2 cm to the left, right? You will notice they stack exactly at the same point. Now this is the feature of it. When you have telescope, right? It's always like that one. The middle point here, the FO and FE, they stack together. But of course, they are different because why? You see, FO is like this. This one is your FO. And then FE is like this. Sum together become the distance between them. So because they must be equal, that's why you get stacking together. All right. So these are the basic structure you must know. Okay. Focal length is provided. This one no need memorize one. It's given one. All right. Just that I prefer this because easier to draw. So once you settle this, we can start drawing. Okay. Then you start thinking one simple question is that telescope. What's the function of telescope? We use telescope for what? Telescope is to look at very far away things, right? Yes. No. That one binocular. Some of you were asking like hey. Do I use that to look at my neighbors or stare at my neighbors? That one is you stalker, okay? Basically, right, telescope is look at things that's very far away, like stars, the galaxies and everything. So here's the thing. Whenever we have object coming from very, very far away, we assume those objects as infinity object. All right, we assume those objects as infinity object. Means what? They come from very, very far away. Because normally when we draw lens, right, we're gonna put like an arrow to represent the object, right? Now that is if your object is nearer. It's like, right in front of the lens. But if it's very far away, right, now we call that as distant object. Distant object, simple. That means you assume them coming from infinity. Means your object will be 3 lines of infinity, sorry, 3 lines of parallel rays. Parallel rays. Okay. Now let me teach you how to draw this, because there are many ways. No, but I will basically show you a dummy-proof way, lah. Okay. Not to say dumb-proof, lah. Is that it's easier in a way. Okay. Now first thing, you think about it. Last time when you're drawing convex lens, what kind of image do you get if you put your object exactly at focal point? If, let's say, we don't care about this object first. If I have object here, what kind of drawing do we get? You ended up getting, go straight, go to F, my bad, go to F, and then go through the center of the lens. You end up getting parallel rays, right? If you put object at focal point. So now, right, you reverse the logic. You think about it, you terbalik the logic. Means what? Simple. If I put focal point, I get parallel. So what if I get parallel? What if I put parallel? Then what happened? I will form the image at focal point. Exactly. So how exactly we can get this simple? Now, first of all, you expect 3 lines parallel like that. Then of course, a bit hard to draw, isn't it? Like, how do I know where to converge? How do I know where to stop? Simple. Now, light ray from parallel, they will form at focal point, because the logic reverse one. You put focal point, you get parallel. So if you put parallel, you form focal point. Okay. So what you do now is you get a pencil. Okay. Later you have to erase off on. That's why you get a pencil. You draw 1 line straight like that at the focal point of objective. Yes, objective. So this one will basically become your focal line, because you know that your light ray gonna focus here, but you don't know where yet. Just that you know exactly these locations. Now, next thing what you do, simple. You draw 1 straight line. Anywhere else again. Anywhere else again. Any angle also can. Basically, just 1 straight line go through the center of the lens. Now, why do we do that? Simple, because right, when light ray go through center of lens, there's no bending one. They go just right through. They just go right through. That's why we can draw straight all the way to here. All right, that's the first thing. Okay, that's the first thing. Now, parallel, how to draw? I suppose you all have the the plastic ruler, half transparent one, the typical one, the 50 cents you can buy one. You can use the center line there. You put your ruler on top, then whatever line you draw will eventually become a parallel line. Yes, so what I do now is, I'm gonna draw another line that is parallel to the blue one. Now I look at the red one, I stop here. Because why? Now this one got no bending because they pass through center. But obviously this is not passing through center. There will be bending later. Now, next thing, I draw another line, orange one. Also parallel, but at the bottom. Go through all the way. Now you see, I will stop here as well, because why? Simple. You see, 1, 2, 3. The 3 lines here are parallel to each other. All right. But then only the blue one will go straight through, because why? Simple. Because you go through the center of the lens. But the other 2 is not, because why? They will be bending. They will be bending. Of course, you ask me, then how am I supposed to know? How am I supposed to know where to bend? Simple. This is why I like you draw this line. Now, parallel line, you know they will form at focal point. So what you do, very simple. The cheating way is that now you draw all your line pointing towards the intersection you get just now. The blue and the gray intersection, right? So now all your orange, all your blue color, right? Sorry, your red color, right? You just aim there and draw. Because you know when you have parallel lines, they will form exactly at the focal point. Something like that. All right. So these are the first drawing you get. Now, not done yet. Later, you focus first. All right. This one. So basically, we have 3 light rays from infinity because they are distant object. And then they go through the lens. They will converge and focus to your focal point. Now, once you're done, right, take away this. You're not supposed to have the line. That one is a cheating line. So your evidence, take away. All right. Then, right, you see, since all your light ray forms here, that means what? Your image will form exactly at focal point. And that's what you want. Because focal point, get parallel. Parallel, get focal point. Okay. So this one, your image. But of course, this is only image 1, Because why? You notice you never use any of eyepiece light, right? It's always like that. People think telescope, microscope very hard. It's not true. It's just drawing lens. Just like you draw them twice. You draw once here and then draw again. Yeah, just like that. Now, after that, once you got I2, what you do? Now you treat your I2 as your object. You draw again, going through the eyepiece. And simple, because this one you can do, you got object already, right? So typical you do, right? Straight line, go straight, and then we go to focal point because this is a convex lens. Second line, how to draw? Simple. You go through the center, always a light ray going through center of lens. There won't be any bending. Now, obviously, as you can see, the light ray is not intersecting because they are having a parallel lines. So what do? We extend the line. Oh, by the way, extension using dotted, we extend the line like this. All right. So all these are dotted, 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 to prove that they will not intersect either way, whether left or right also, there won't be intersection. So basically, this is where you put your eyeball. That's why I call eyepiece. And you will see infinity. This one is your image 2. Exactly. So that's it. Telescope drawing. All right. They look scary. If you look at the whole thing, one shot, they look scary one. Ultimately, you can see. Draw objective first, parallel to focal point. Then take the image, draw again, you get your image 2. Simple. Now I let you look at it. You can try drawing yourselves. Okay, next we have microscope. Same thing. First thing first, we draw the straight line for your microscope. Okay. Now, microscope, telescope, same. You're gonna have telescope, you're gonna have like objective lens and eyepiece lens. But the logic is reverse one. Because why? Now, telescope is for you to look at things that's very far away, But what about microscope? Microscope is for you to look at things that's very tiny, very small. Okay, like plant cells and stuff like that. Right? Now, same. We're gonna have your power. We're gonna have eyepiece and objective as well. But then, right, for microscope, your objective power will be larger than eyepiece. You can see the bale one. You see, for telescope, eyepiece bigger than objective. For telescope, power of eyepiece larger than objectives. And then for power of objective, it will be larger than eyepiece because it's microscope, the balik one. So that means now, you see, focal length, the balik, right? FO shorter than FE. Now, same also, we're gonna use the same drawing anyway. Like same measurement. So just that, just now I got 6 and 2 cm. Before that, the 6 cm was FO. And then 2 cm is FE because you are drawing telescope. But now, right, your FE is longer. So I take this as my 6 cm and then this one as my 2 cm. Now that's the first thing. The power, you have to remember big or small. Which one bigger, which one smaller? You have to choose one. Now, second thing, the distance between the lens also different. For telescope, you want it to be equal, FO plus FE, equal to FO plus FE. But then for microscope, right, your distance between the lens, you want it to be larger. Exactly, bigger than FO plus FE. Now, simple, FO plus FE means 8. So that means you have any number larger than 8 also can. Normally, nobody asks you you go like, oh, larger, I put 20. No lah, you larger by a bit will do because you have to understand, ultimately your graph paper is just this long. It's not enough space one. So normally we will just larger by a bit. Yes. Now, basically, right, what happened now is, you see, first thing, objective, it's shorter now for your focal length. So what happened there? Simple. You can put your lens slightly towards the left side now because you don't need so many space anymore. So you could just put it, slightly to the left. You don't have to leave so many space like what you had before. Because before that, you got long focal length for objectives, right? But now, right, your objective is only 2 cm. 2 cm means literally here. Exactly. So what happened? Simple. This one is my objective lens. All right. Oh yeah. 2 cm will be somewhere around here. FO. All right. Again, 2 cm FO. Right. Now, the distance of the lens has to be larger than 8 cm. So what do I do? Simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I will just put 10. You can do any number you want, but normally, I recommend your larger, don't larger by too much. If not, again, drawing will be quite hard to draw one. Okay, you got problem drawing anyway. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, this is where I put my eyepiece lens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. All right. And then now, right, this one is your eyepiece. How we do that? Simple. Now, you measure from your eyepiece 8 cm. You measure from your eyepiece 8 cm. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 cm, 6 cm. 6 cm, sorry. 2 and 6, all right. 1, 2, 3, 4, 5, 6. You put here. So you can see the difference compared to just now, right? For telescope, your FO, FE stacks together one. For microscope, right, there will be a tiny gap here. Yes, there will be a spacing between them already. But yeah, that's the whole point. 1, 2, 3, 4, 5, 6 cm, and then you put here. All right, so that is the difference. So ultimately, right, for your microscope, ended up what happened is actually, all right, the distance between the lens is actually equals to FO plus FE plus the tiny gap in the middle. So that's why it will be larger. That's why it will be larger. You get what I mean? So for this case, right, this one is your setting up for your telescope, sorry, for your microscope. Now, again, those focal length is given now, right? You don't really have to, memorize the length one, just that these are easier to draw. That's why I prefer this. Okay? Now, how to draw? Simple. See, start thinking, what is the use of microscope? We use it to look at things that's very small. And where do you put the object? Imagine in biolab, what do? You put a sample right below, right underneath the lens, am I right? So the object will be very near. Okay? Now, but there is a requirement as well. You see, this one there's a requirement because why? Now, normally for lens, right, we got focal point, and then normally we have another one here. It's called 2F, right? F and then 2F, right? Now, for object, right, you want to put between FO and 2F. All right, you want to put between FO and 2F. Now, the reason very simple. First thing is you want to put it after. You want to put it longer than focal length. The reason is because you're trying to form a real image. You can only form a real image if you put object here, anywhere after focal point. If you put it on focal point or before focal point, right, then that will just be a virtual image. Now, what's wrong? You're trying to form image to the eyepiece. So you need to have a real image from objective to project to your eyepiece. You understand? You're trying to project over, so that's why it's a real image. That's why first thing you want to put it after focal point. Then of course you ask, then why must I put between 2F and F, right? Why can't I just put at 2F? Why can't I put here? Why can't I put here? Since all these are going to be real image, right? Now, second thing, microscope for what? You want to magnify your object. You want it to be larger, am I right? So you need to put your object in between F and 2F. The reason is because by putting here, you get a real image, you get a magnified image. It becomes enlarged. Yep. But later, when you're drawing, right, don't put your object too big. You will regret one later. Because why? This thing is to magnify. It magnifies things crazily. So that's why if you put your object like that, crazy big, right? Later your image is going to be even crazy. So that's why normally you put like a tiny one, a small arrow there, and we go on. You understand? Yeah. Now we go on some more. How we draw? This one's simple. Draw as usual. Draw as usual. First one, you go straight. Right? Typical drawing. Okay, go straight and then go to focal point. Aim correctly. Some of you will aim wrongly, you go to the FE one. This is objective, so you go to the focal point of objective lens. Something like that. Now, second line, right? You go through the center of the lens, typical, all right? And then your image will form somewhere around here. Now, your drawing might be different than mine. It's fine because my one is not exactly 2 cm. All right. Now I need to make the lens longer. Doesn't matter one, lens longer, shorter. All right, like that. So this is where I have the first image form. From here, image number 1. Now, this one, right? How do you know whether you're on the correct track or not? I2, your image, sorry, I2, your image 1, it needs to form here, within this region, anywhere lesser than FE. Anywhere lesser than FE. All right. Then only you can continue drawing on. If you say, oh, my I1 form here, then too bad, I need to redraw already. Your answer is going to be wrong. So that's why I asked you to put your gap, right? Not to be too big, because when you get too big, your I1 will land in between the gap instead of like, over here. Now, I1 settled. What we do next? Simple. From here, we draw a straight line all the way. Okay, typical lah. You treat this as an object and then draw again. Now, make it bigger lah. Okay, because your image is a bit too big already. Okay, saying it. Sorry. All right, piece. Treat it like an object and then redraw again. So from here, I1, go straight all the way and then aim to your focal point. Typical, all right, converging lens, go straight, go F. Second line, you go through the center of the lens. Now, look at the orange line. Does it look like a parallel to you? This one is not parallel. This one becomes parallel, then you need to change your specs already. Well, simple. It's not gonna get intersection anyway. But you see, it's getting bigger. Then you reverse the logic. If it's getting bigger here, that means what? That means it will get smaller there, right? So extend your line using dotted, of course. Extend your line using dotted, and then ultimately you will get intersections very far away on. Actually, no worries about that. It's meant to be this way. Okay, so this is where you get intersections. This is where I have my final image. All right, now intersection here. This one is my I2. There you go. This is my final image. All right, don't forget arrow, very important. Go straight, go to focal point, go through the center. Now same thing here. Go straight, go to focal point, go through the center of the lens, and then you will form an image exactly. I mean, now must it be exactly F4? No, just that this one just so happen is there lah. Yeah, y'all might be different. Y'all might be somewhere here, somewhere. It doesn't matter. I2 location is not done. Only requirement is your I1 needs to form lesser than F2. And you can see, right? Look, originally this is my object. This one is my tiny little object. Yes, and then ended up become a crazy huge one. That's why I want you to make it small, because if not, you'll regret later. And that's it. This is a drawing for microscope, just like that. Treat it like drawing for a lens, and then you draw again. All right, you see, draw one, and then draw two. You don't have to draw one shot one. Just treat it like two lenses, and then you draw them separately, and that is your drawing. Okay, all good. I hope you understand everything.